What we are going to discuss is first, I would like to throw some numbers because morning I have got to know from various people that they want to know some economics with respect to some of the clean flow technologies. I really appreciate that, and then what I would like to say is using CDM, how this energy reduction or maybe the coal consumption reduction will be possible, and how can we convert that into an opportunity. If you see, this is the basic slide. I think most of us know about CDM, chain development mechanism. How many of us know? That's good. I can spend some time on that also. So there is a legally binding reduction targets of GHGs, greenhouse gas, especially those 6 greenhouse gases we are talking about: carbon dioxide, methane, N2, PMC, HFC, and SF6. These are the 6 greenhouse gases have been identified during the Kyoto Protocol, and there is a treaty which was formed during the period 1997. The treaty says by at least 5.2% below 1990 levels in 2008 to 2012. This is the commitment period. They want to reduce the CO2 emission targets. So for that, they have established various mechanisms. Because if you see this particular Kyoto Protocol is first started for only those developed countries. So they have classified the countries into developed and developing. I think you may be aware. India, Brazil, South Africa, and then China. So these are some of the developing countries like European Union, and then Australia, all those countries will come and develop. They call us developed countries. So they want to establish a mechanism which I would like to explain more when we go through. To start with, I'll just give it briefly. So there are 3 mechanisms as of now. One is a clean development mechanism, and second is an international emission trading, and third is the joint implementation. I'll take you each and every mechanism how it operates. Before that, how these numbers look like? Obviously, there's something which is highlighted in red. I'll tell you why it's mentioned in red. See, these are some of the CDM projects, especially taken up by the project promoters to get additional benefits. If you see, for example, you take up the Adani Power Limited, so which I am going to give you case study also. These are the ones we are going to discuss only case studies, and I would take you through the case study, and then whatever questions that you have, you can please feel free to ask us. To start with, you see Adani Power Limited. They say there is emission reductions of about 18.39 lakhs. So that's a number of big number. And this project, in addition to their regular revenue by sale of power, they can achieve another 552 million per year. For next 10 years, they can get it. So we will get to the technicalities of that. And next, this is again a Chinese project. I think you don't see the methodology number. Again, I am mentioning that. So this is going to have an emission reduction of about 92,000, and where is going to fetch about 27.6 million per year INR. And again, this morning we have discussed about CEAC. It's again an emission reduction project. It's going to give us a CR of about 4,000. So how these projects are reducing emissions? CO2 emissions. So let's go to Adani. So Adani Power, they are putting up, I think they have already put up 660 to 2 supercritical power plants. So these are some of the details which I have given. If you see, the project cost is about 5,796 crores, and given certain project cost details. So how CDM is going to help Adani? Adani should take up CDM. If you see, Adani has put up a supercritical project. So they also have an option of putting up a subcritical project. So I think most of us know the difference between supercritical and subcritical. people from village here. So because the subcritical, if you see, it is the common practice in India so far. But they wanted to put up subcritical UTC because this is again, though there is a cost escalation, I think people can see subcritical may cost you about 4,350 crores, whereas this plant of 662 megawatt Adani is going to cost about, so it is about 5,796 crores, where the capital cost of more than 15,000 crores. Sorry, not 15,000. It's about 1,500 crores. There is an additional cost to it. So how are they going to do it? But where do they want to put it? If you see the second one, there is a station heat rate reduction of about 150-200 kilograms per kilowatt hour. So, is it making some sense to us? Because they wanted to put up an efficient system which is going to reduce the coal consumption, thereby reducing emissions into the atmosphere. But at the same time, this particular technology is also costly. So how are you going to make up the additional revenue? That's how the CDM is going to play a role. Now let me start. What is CDM? CDM is the mechanism which is between a developing country and the developed country, that emission trading. In the sense like whatever the emission reduction projects which you take up in a developing country, so that project, whatever the emission that you reduce, that can be converted in the form of a certificate. So that certificate can be traded into a developing country. Thereby you will get money out of it. So why these things should happen? The developed countries have a mandate, as I mentioned earlier, they have a mandate to reduce CO2 emissions in their facility. That means like, say European Union, they have their own compliance, CO2 compliance. So they have to reduce say X percentage of CO2 from their countries. So this X percentage will boil down to the industries, power plants, etc. So each and every industry, each and every power plants, they are going to have a target. That means, say they may give a target of say 0.5% or 1% whatever. But cost of compliance in Europe, if you see, it's going to be like very high. So it's about 60 euros to 70 euros. Whereas if they can purchase these certificates from a developing country like us, it's going to cost them say 10 euros or 11 euros. So that is the primary mechanism, that this particular mechanism was so successful for the last 10 years, and lots of projects are registered and many project promoters, they got revenue from it. So that is the primary, the fundamental of the CDM. Now we can ask me a question, so what are the projects like this are applicable? So in addition to this energy efficient projects, there are certain other projects which are also applicable. I will not take much time about it. So renewable energy projects, most of the renewable energy projects are applicable. Fuel switching, as I said, energy efficiency, cogeneration, waste management, transport. There are varieties, there are about 16 sectors or 16 varieties, not 16 varieties. Like each and every sector you have different varieties of projects. So there are more than, you can say about 120 varieties of projects is possible, to get additional revenue from the sale of carbon credits. So now let's see how this mechanism is going to work. Each and every project has a project schedule. So you identify a project, say for example, a supercritical project. So you identify a project, yes, I have conceptualized that I am going to put up a supercritical project. So for that you place a purchase order, then you go for a coal linkage, ash linkage. So each and everything you start putting up your project schedule. In parallel, what you have to do is, suppose if you want to get access to these funds, so there is a modality which is being fixed by United Nations. That is, they are the nodal body. They call us United Nations Framework Convention on Climate Change. They are the nodal body who takes care of this mechanism. So they have asked us to, do some activity in parallel to the regular project operation. If you see, so first you have to prepare, in parallel, like if you have a project identification. So at that time, like I've said, you have to come up with a prior recognition to your unit admissions. That means, say I'm going to put up a 30-40 megawatt in so-and-so location. So I need an additional revenue because of, say, my project cost is this, and I am able to reduce this much amount of emissions. So we have to come up with a prior recognition and we have to send it to generation. That's the first step that we have to do. Then when we started moving your project schedule, then you also need to start developing your senior management. The next step comes to your, you have to come up with a project concept. These are some of the documents which are required. The next is the project design document. These are the two key documents that you have to prepare. Then you can give it to the unit administration, they do a validation. Then your project gets registered. Then from the date of registration or in the date of commission, whichever happens later, you will start doing your credits. That means like each and every unit that you generate, that will accumulate a certain number of credits. So let's see how much it is. If you see an electrical energy saving project, roughly will get you about 1 unit will get you about 0.9 to 1 kg of CO2. And maybe from renewables, it's about 1 megawatt will give you about 4,500, depends upon the plant load factor. And 1 kg of coal will get you about 1.8 to 1.6. There is a fuel oil saving, is a figure that we have. So now, how to take up? Suppose if I have a project like another project, how do they want to take it out? So when they want to take it out with the unit emissions, the first thing they want is a framework. The framework in the sense like, say for example, say Adani is putting up a project, Tata has put up a project, Shasan is putting up a project, Jharkhand there is another project which is there. Like in China there are millions of projects like supercritical projects coming up. So if each and everybody started writing the project design on their own, then unit emissions will face a huge problem. So in order to synchronize everything, so what they have done is they have come up with an algorithm that they call as methodology. So that's the reason you can see this number here. There is a number which is there. So what they do with their idea, you want to develop a methodology. Say for example, I have a project, I have a supercritical project. So what do we need to do? First, I need to develop a methodology. Or if there is an existing methodology which is available to unit emissions, you can use that if it is applicable to you. So first what you do when you develop a methodology, so then you have to come out with various options. Say for example, if I did not put up a supercritical power plant, then what would happen? Can I put up a critical power plant? Or I may put up a natural gas power plant? Or I may put up a renewable power plant? Or I would have invested in relation systems also. That anything can happen, right? So but you have to come out with a proper alternative that which I am going to select. So they have given 3 types. Your project can come out with an existing or historical emissions, or you may put up a technology which is most prominent in the country and economically attractive, or you can select say recent last 5 years or recent 20 plans which is added into the government portfolio. You can take any one of this. So these 3 options are there with your idea. And using this, you can develop a methodology, or if you have an existing methodology, you can use it. Let's see an example. I would like to take this, the methodology for supercritical programs. So I would not say this particular methodology is applicable only to supercritical programs. This is applicable for the more efficient technology being implemented in the power plants. So even it can be LGCC, that is also applicable to this program. But you have to come out with proper justification to the points given by unit emissions. Say for example, they say there is each and every methodology will start with an applicability condition. That means like this particular methodology is applicable only to these conditions. So I would say the first thing, it should be a fossil fuel power plant. They say, okay, our supercritical power plant is a fossil fuel, it's a coal-based power plant. They are importing coal from other countries. So they say that should be 1 fuel and auxiliary fuel should not be more than 3%. Yes, coal is going to be the main fuel and auxiliary fuel is going to be less than 3%. and they also see it should not be a cogeneration power plant. So this is like cogeneration power plants, like this is going to be a power plant, so like it's a state condensing mode, there is no cogeneration involved. So like that we need to satisfy each and every condition given by the conditions for proving our applicability. Next comes, this is an interesting part. If you see, they have asked us to come out with an alternative. So as I said, what you would have done if you would not have put up the supercritical power plant. So what you have to do is that, number one, we need to come out with alternatives. So I would have put up a subcritical power plant or engine-based power plant or renewable energy-based power plant. Now I would not have even invested it, I would have invested in fact. So we have to come out with all 10 alternatives. Say 10 or whatever number it is. Then we need to remove each and every alternative through your one, say for example, you have expertise in power plants. Obviously, you will be investing only in power plants, you will not have invested in real estate business. So therefore the real estate will go out and say natural gas. So the place where you want to put up a power plant, natural gas will not be available. The natural gas will go down. So then comes renewable energy. So I would want to get a payout of say 80-85% because I need to give a continuous power to somebody. Say, because this particular project, if we say they are giving power to trainer, so at a percentage of around 80-85%. So if you put up this money, say for this 5,700 crores of renewable energy, which is informal in nature, so you would get about 20-25% payment. So you can't be there. So obviously that's so. So like that, we have to remove each and every alternative. Or not remove in the sense they have to knock out each and every alternative. Then come out with the plausible and credible alternatives. So the plausible and credible alternative for them is putting up a subcritical power plant, because most of the parameters, if you see in the next slide, barring these two parameters, which is marked in red, all the parameters are same. So they want us capacity of 1320, it's available in wood, and payload of 20%, quite possible. Auxiliary of 7.5%, yes. There's a discounting factor. GCV of 4 is same, price is same. But the parameter that you see, the project cost, which is high, it's about 1,500 crores, costlier than subcritical power plant. But if you see the station heat rate, yes, they are getting an efficiency rate. It's about 150 kilometers per kilowatt hour. So this is how this particular project can be considered for CD. In addition to it, there is one more point which we need to think of, is the additionality. I think additionality means why I should require revenue from the sale of carbon credits. Because we have to inform United Nations that yes, my capital cost is high, but the overall returns will be good. Say for example, you put up a project where the internal rate of return is say 14%. And CRC says if you put up a project with the internal rate of return 14% is viable. So that is the value revenue for advantage. And if you are putting up another project, say you are getting an internal rate of return of 20%, no, then you will not get any advantage. So we need to work out a detailed internal rate of return calculation. But specifically in this case, we have to come out with the levelized cost of generation. If you see here, the levelized cost of generation for a subcritical power plant is only 2 rupees 2 paise. Whereas for a supercritical power plant it's about 2 rupees 14 paise. So that's where this levelized cost of generation, if you see, this is being calculated for 20 years, considering the similar interest rate, payload, etc., etc., etc. And then, of course, you are also going to get a wholesale. So you have to work out a proper financial analysis. You have to present it in a more transparent manner to United Nations. And if you are able to present it and if you are able to convince the UN representatives who validate your project, then this project will be considered under CDM. So these particular projects have been considered under CDM and they were getting a serious of about 18.3 million. Okay, so what are the methodologies to do the investment analysis? Yes, sir.
see the capital cost also on the higher side.
Yeah.
Operating cost also on the higher side.
Yeah.
Even considering the carbon credits, one may receive, say around 500 million per annum. That means that is excess capital cost is 14,460. And so for 15 years, they may have to receive that carbon credit.
10 years later. Because you will be getting carbon, because when you do a cash flow analysis, you have to do a cash flow analysis with CDM funds and without CDM funds.
Normally, any investor will expect a payback period of 4 years, at the most 6 years. Here it comes to 15 years.
No,
That is 57,960 minus 43,500 is 14,460.
Yeah.
Around 550 or 500.
Now 552 is the figure which I have considered, which is conservative. Because you see,
what is maximum one can get?
They can get twice also. Because see, the CR price which I have considered from carbon credits, it's 5 euros.
Can you simply say in how many years they will come back the excess capital cost involved?
So that a payback period I can work out and definitely they can able to achieve within 4 years, 4 to 5 years. Why? Because now the carbon market is very low. When this project was registered in 2009, that time the carbon prices were 14 euros per ton. Right? So just consider 552, I considered 5. Just consider if it is 14. It's almost 3 times.
The vital factor is increase in operating cost, 10 pies, 12 pies.
Yeah.
That's also be the cost.
That's actually your capital cost, your operating cost, everything is included. That's how we do the leverage cost of generation. When we do that, so your operating and capital cost, the part of the capital cost is the depreciation amount that has already been considered in your capital cost and in your leverage cost. Then you will consider all your coal expenses, etc., etc. Then you arrive at what is going to be a PPDIDA and for the subcritical, then for supercritical, then you come out with the leverage cost. So what actually should happen is, by considering CDM funds, okay.
Can it be expensive for CDM? Sorry,
no problem.
Expensive for CDM.
3,000.
I went up slept.
Ultimately, what we are suggesting is investing that 14,000 crores in cumulative value is perfect.
Yes. Yes. Why I'm saying is that if you invest, just imagine. Now I consider only price of about 5 euros. It's because this is very low. Now the market is also very low because of euros and prices that you will be already aware of. And number two, the crude oil prices are also going up. And most of the European nations can now they start switching from coal to gas because the import coal price is also going up. Like now it is around $127. So they are not able to buy coal at a higher price. So they are using natural gas, which is there in their resource. So that is a primary reason that it's hitting the CR prices like anything. But 2-3 years ago, not 2-3 years, this is about 1.5 years ago, the prices were running at around 12 euros and it was there for the last 7 years. 7 years the prices are around 12 euros. So I have considered the most considered that is I am getting a figure of about 20-25 crores. Otherwise, just imagine I can show a figure of about 100-120 crores. So that's I think when we see that a lot of people even when we come to a bid also, you have seen like right from first everybody is trying to put up these supercritical power plants. Yeah, please.
This mechanism is really suppose Telangana government plans 1 lakh forest. Listen, we have enough of wastelands, enough of land where there is no green cover. And then what still was land, nobody uses it. Suppose if Tamil Nadu government tomorrow decides to plant 1 lakh hectares of area, will it become economic for city?
Yeah, of course. Yes.
Why we are?
Pardon, sir?
Why it's part of the question? That is going to give you benefit to you state. We are a developing state, developing country, where this kind of we can trade. That's number one. That is a project where simply we are getting credits, 100% credit we are getting probably there. So I don't know why, where as a nation as a whole, if they take up under that vision, and even first of all you can benefit yourself to the country as well as you can trade, get the trade also. Number one. Number two, suppose any entrepreneur, anybody wants to build a say power plant, say supercritical power plant. So even that operator is also obliged to reduce some emissions, isn't it? The credits are after that one or the whole credits you are getting.
No, you will get the whole credits. But actually, sir, now
we are also obligated to reduce some emissions, isn't it? Some emissions, because it's not like only Europe and other countries they are to who are buying the credits. They are only to obligated. We are also to reduce some emissions in our country also.
I will answer one question one by one. The first question, when you say, when you develop a serial project, this especially this electricity generation projects or even afforestation projects you're talking about, there are certain key points which you have to do. Okay, I'm coming to that point also. First of all, when you're putting up, say for example, 1 lakh hectares, you want to put up, okay, so 1 lakh hectares or more than 1 lakh hectares, you want to invest on planting. The prime thing is that there is something called monitoring. Okay, monitoring in the sense like we need to monitor certain parameters to evaluate your emission reductions. Say, in this particular case, if I say, like I need to put up a child meter to monitor how much amount of electricity is being generated. That's number one. Number two, I need to monitor the gross calorific value of coal on a monthly basis. Number two. Three, I need to monitor the ultimate analysis and proximate analysis of coal on a frequency basis. Then comes four, what is the transportation emissions is happening because of my project activity. So these are some of the things which you have to monitor. But in the case of afforestation project, you need to monitor, okay, what is going to be the size of the tree, what is the rate of growth of the tree, so how many trees are being planted. So though you are going to do on a sampling basis, you need to also see that whether there is also a natural carbon which is happening, right? That is number one. That you have to evaluate. That's number one. You have to take a lot of IPCC values. Number two, there are going to be tree shedding. So for next 10 years, there should not be any tree cutting the trees or maybe grazing. So you have to protect this tree from grazing. There are lot of parameters which are there which you have to monitor. That makes these type of projects so difficult. That's the primary reason that these projects are not working well. Otherwise, these are one of the, especially afforestation projects are the best projects because they are straight away, getting the CO2 reduction, CO2 abatement. But because of these, primary monitoring parameters, these projects are not coming up properly, especially in India as well as even outside also. Because even ITC registered a first project. When they developed the first project, ITC Pulp paper, they have registered the first project of afforestation. But if you see the issuance, that is ultimately to get your money because the registration is the first phase. Then you will have the issuance. The moment you register your project, then you have to accumulate CERs, then you have to trade. So the accumulation of CERs, they don't have a proper monitoring system. Or the monitoring system is so failed that they were unable to calculate how much amount of emission reduction they have actually achieved.
They have devised such a formula.
I would not say the common formula, but it's something like that. Yes.
Because see, what is our own nation as a whole?
Because we are going to do our every policy department in every state. They are collecting lakhs of trees. Every policy department, so that doesn't come under that. The policy department is also planning, increasing the size of the forest cover. Maybe where they are cutting, so that will become minus. And suppose cutting 1 tree and planting 10 trees, forest department is doing it. That should not come under this mechanism.
No, that's what I'm saying. That's what I'm saying. Deforestation and afforestation, yes, it is an eligible serial project, provided this monitoring parameters needs to be filled in. Because they have come up with such a, even I am telling you, this particular methodology which I am talking about, this has an inherent risk, which I am going to tell you, because I am going to just come to this point. Because if you see this many plants, say for example, if 15 plants have come up like this, where the emission is of 18.5 lakhs, each project is about 185 lakhs CEs if it comes up. And it is directly going to hamper the people who are going to, invest in smaller energy efficiency projects, because ultimately the CEs are going to the European market. Like India develops 10 projects, so China develops 20 projects, Russia develops another 30 projects. So within some 20-30 projects itself, like the entire CE on the CO requirement of Europe will get over. So then how you will, how the projects like small scale projects and renewable energy projects, how these projects can generate CEs. So for that, they have put up a cap in this. So they have devised a methodology such a way that this methodology will die on itself. In the sense like they have mentioned, when you are developing this project activity, you have to do some kind of a common practice analysis. So you have to take the plans which are getting implemented in various states, and you have to rank them according to the efficiency. Say the efficiency, the highest efficiency plant will be at all. It includes the supercritical power plant. When Adani was developed, there was no supercritical power plant. So I think Talcher NTPC, Talcher was the highest efficiency. Like that they have, we have to list down all the efficient power plants. Then select 15% of that. That 15%, in that you have to take the highest efficient plant. That plant is going to be a baseline. If the high efficient plants are more than 15%, then nobody will get CDP. Say for example, the 15% will, because we have worked out this, there were about, I think 10-15 plants have come up, and 15% of that plant is comes to two numbers. Say for example, in our country, if 2 supercritical power plants have commissioned, they show that yes, they have commissioned it, then the supercritical methodology will die on itself. Because after that, the baseline itself is going to be supercritical. Then you have to say, for example, 2150 is the kilocalories per kilowatt hour that they say, and if you come up with say 2095, then 2150 minus 2095 is going to be the emission reduction. Whereas if you see in this case, it is 2398 and 2150. So what I noticed, this is like a moving baseline they used to say, because they also, of course, one side they are promoting this technology, and the other side they don't want everybody to get the benefit. That's why you will suppress those people who promote a new technology. So this is exactly each and every methodology. If you say there is an inherent nature in this, that we have to address these issues, promptly, because these people are like first movers. Say for example, about 6-7 projects are already registered with supercritical. I think I have the data with me. Yeah. If you see the projects which are already registered is Adani, Sassan, again another more project they have registered, Postman, Jharkhand. These are the 5 projects which got registered. But even these projects will face a lot of challenges too, because globally a lot of people will put, because this project will be there at the website for global comments also. So that period of time, anybody there can comment, because people have commented left, right, center for this project. And we have to address everything. It's first tough, but at the same time now I think we are going to deal with it. Yeah, actually I was mentioning about one particular point before I went up this case with you. When you do an investment analysis, I just want to make one point. There are 3 ways we can do an investment analysis. Number 1, you do a simple cost analysis. This is like, I am not going to get any return out of it, but I am investing in it. I am investing in it. Okay, so that you can do a simple cost analysis. Or number 2, you can do benchmark analysis. Number 3 is investment comparison analysis. So when you do a benchmark analysis, say for example, I am going to put up a greenfield project. Say for example, I am going to put up a wind project, say 10 megawatt. I may put up this project for an accelerated depreciation, however, these wind projects, as I said, renewable projects are applicable for CDM benefits. So, in the absence of this, what I would have done? Okay, this much of electricity would have been generated in the grid. That's what normally people do, because if I am not generating 10 megawatt of electricity from renewable energy, then this much amount of electricity would have been generated from the grid by some fossil fuel-based power plants. For that, we don't compare this wind plant with something else. So then we have to come up with some kind of a benchmark. For that, we have to calculate a weighted average cost of capital. So that is going to be a benchmark, and you have to come up with your IRR and you have to compare this. Number 2 is the investment comparison analysis which was conducted in this project. So they have compared the supercritical plants and the subcritical plants. They come out with the lowest cost of generation. I mean, you can come out with IRR and NP, whatever it is, the best financial model which you can work out. Then you can demonstrate your.
Now, we are having this levelized cost, including these products.
Yes, sir. What further what you have to do, as I said, we have certain basic assumptions which is involved in it. So this is your assumption. So this I have mentioned for supercritical. Okay. Like this, you have to make it for subcritical also. Find out what is your accelerated depreciation. Like accelerated depreciation with respect to your Companies Act, your Income Tax Act, subtract it, find out what is your loan component, take it out, then what is going to be your annual operating expenses, and what's your revenue, then revenue minus expenses. It's something like a cash flow analysis that you have to do. When you come to the net cash output, that you have to convert, that you have to divide by total kilowatt hour. Kilowatt hour, that is units, number of units that you are going to generate. That you have to count the discounting factor also, because discounting factor can be even your 9% or 8% or that you can take it up. And take that also you come out the proper justification, so that you will take it for next 20 years. You have a discount, say for example, today I have 100 rupees, but next year you have, say, but today the 100 rupees is not, cash. So that you divide it and sum it up with everything, and you come out with the figure. That is the cost. So now I think you get some idea about CDM. This I think maybe I thought it's a little bit useful. I think in future also there. So if you see, this is a Chinese project which they have submitted for registration. It's not yet registered. So that is the primary reason that I mentioned this project in red. You have seen the first slide. So they are going to do a retrofit in the steam turbines, and I mean this is steam turbine. They are going to do a retrofit. They are given the rating is about 500 megawatt. It's designed in Russia. Commissioned in China in 1996. Why doing the retrofit? They say they can able to reduce the kilocalories per kilowatt hour, specific energy consumption by 80 kilocalories per kilowatt hour. It's a bit by 80 kilocalories per kilowatt hour. So what they did, they have just did some retrofit. They have changed some rotor blades, rotors, blades, diaphragm sets. So these are some of the 4 or 5 parameters which you have changed. Because I just want to throw some example, because whenever you come across these type of projects, like when you do a turbine retrofit, yes, because normally people will think that okay, CPM means like it is applicable only for renewable energy plants, but no, it's applicable for energy efficiency plants, it's applicable primarily for power plants. I am going to discuss next case studies. I can run through this right because of the paucity of time. I can just give you. So this is the project. So for this also the methodology is AM62. This is specifically designed for turbine retrofit for steam turbines and gas turbines, where the fossil fuel is going to be important. You can for boiler and then you have a steam turbine, you do retrofit and steam turbine. That retrofit, whatever the energy saving is there, that you can convert in the form of carbon credits. And for the same is applicable even with the gas turbine also. Just in a nutshell, so they have mentioned their coal consumption rate, their calorific value in terms of megajoule per ton. So you would be surprised why for megajoule per ton, because the methodology would have is as for it. Normally we check kcal per kg. So it depends upon the methodology. And if you see their net heat rate before retrofit is about 855.6, whereas after retrofit it's reduced to 821. The difference in heat consumption to generate one amount of electricity, 1 unit of electricity is converted into CFS. That is going to be about 92,000. Even here also, if we say it is 27.6 million, considered 5 euros. There was, as I said, there was a case where the CFS were even trading at 14-15 euros. And again, it's a small scale project because I'm talking about a CR volume was more than 60,000. If the CR volume and emission reduction, CR is certificate emission reductions. If the CR volume is less than 60,000 tons or 60 kilowatt of energy saving or less than 15 megawatt, if any of this category is there, then they will be considered small scale. And the small scale CR, if you see, is about 4,000 CR, which I think Shivaji was registered with the CESC. They have did some modifications in their thermal power plant. And this one I find it very interesting with respect to renovation and modernization case. I think there was one gentleman discussing about R&M. So even R&M projects are very much applicable. R&M or railway extension project is very much possible to consider under CDM. Even we tried with the APG also once, but unfortunately due to some primary reasons the project did not go through. But even there is no even project was on the list. That's just like to give me the case study on this methodology. However, if you see there is a grid connected power plants where it's being operated for more than 10 years, and if you're going for a retrofit in your plant, you're going to consider an R&M or rehabilitation that you're going to do. So whatever the measure that you consider to either improvise electricity generation, keeping the coal constant, or reduce the coal consumption, keeping the electricity constant. So definitely, those projects can qualify for CDM, and there is a applicability criteria behind that. So this is how the project works. If you see, that's what I was mentioning. Earlier is to consume more fuel, but you emit more CO2. By doing certain R&M, yes, you reduce the fuel consumption. You will reduce CO2 also. That whatever the reduction is there, because here also you can because when R&M activity happens, it's going to be huge energy saving is going to be there. I mean, it depends upon what type of measure you take. That's definitely it's a very good project that can consider for CDM. So I can just keep these items. So why this we have discussed is in addition to that. We wanted to show some technologies like I think you might be aware, like always for combustion. And tomorrow, when Tom Texas is going to talk about CCS, carbon capture and storage, which I cannot discuss today specifically because he is going to talk about CCS tomorrow. Even CCS in CDM. So in addition to that, these are also the key technologies developing. These are also applicable for CDM. If you see, public fuel network boilers, BFBC, IGCC. Because wherever you feel that yes, there is an efficiency improvement, of course, those projects can definitely consider for CDM. So while you do CDM, there are certain key points which I would like to say. So when you do CDM, first you have to get the Ministry of Environment and Forest approval, without which you can't take this project out of our country. And your project, any CDM project will be validated by the representatives from United Nations. They do a thorough validation on your project. If they feel that yes, your project is eligible for getting carbon credits, then only your project will go to United Nations. Otherwise, they reject it. Even some of the projects even they get rejected. I think even one supercritical project also got rejected because of certain problems in the input values. Of course, once you have registered, then you will get your CRs. And buyers, I think we were discussing on buyers also. Predominantly, the main buyers are there in European countries. But as I said, due to three main reasons, the market is not so good. The CR prices are probably somewhere between 4 to 5 euros per ton. The primary reasons are the market itself, in the sense like the crude prices, of course, it's going up, number one. Number two, you have the Eurozone prices. They are facing a lot of prices. Number three, of course, the coal to gas, which I was talking about, because of the import process. Cost is going up, and when the euro weakens against US dollar, obviously their cost of import is going to be very high. So they switch from coal to natural gas. So when they switch to coal to natural gas, obviously they themselves, because natural gas is an efficient fuel compared to coal, because natural gas you have hydrogen also. So that will pull down their allowances. So they don't buy that much amount of CRs from the market. So these are some of the reasons predominantly the determines the CR price. And there are primary market price indexes. I give out my UK. These are some of those. I think I would like to complete now. So open for questions. Yeah, please. Yes, sir.
Suppose like income tax, we rework and submit again, will it be considered?
Sorry, I'm not getting it.
You told the project, they rejected the same.
Yes.
Maybe like we file the income tax again and get the money back. Like that, suppose the super real compensation one and file again after changing the figures or whatever requirements they are asking. Will they be able to do it or one time only?
It happened at the cost. You can do it again. Actually, we did it in the past. We did it in the past because there was one, not super critical. There was one waste heat recovery project put up as Sterlite. It was rejected by United Nations. But again, we took it back and then we put up the proper input values and got accepted. Now they are doing it serious.
What is the cost of registration? Cost of registration, including the consultancy?
I think consultancy fees, let's keep it aside. I would say the registration cost is up till 10,000 CERs you have one. I mean, till 10,000 you don't have any fee. 10,000 to 15,000 is $0.1, and if it is more than 15,000 is $0.2. Consultancy we will discuss later. And you have fees for validation. That means when your project is getting validated, of course we have some fee involved in it. They may charge depends upon the type of the project. If it's a large scale project, they are charging for 40 to 50 lakhs. Small scale, they are 10 lakhs. So, should I wrap up?